Hey everybody, welcome to Build Onchain. Today we have Blessing Adesiji from Circle. Blessing, why don't you tell us a little bit about your story and how you got to Circle, and tell us about what you're going to be demoing here today.
Yeah, awesome. Hi, Nishad. Hi, everyone. My name is Blessing, DevRel manager based in London, UK. I've been at Circle for well over 2 years now, right? And I joined Circle from a pretty interesting background. I was working in kind of like the AI background where I worked on large language models and I did developer relations. I did that for 2 years before I joined Circle fully on. So I came predominantly from a software engineering an AI background, right? But doing interesting stuff in the financial technology space, and it's been awesome time at Circle. So today we're kind of going to be talking through how to build cross-chain efficient transfers with CCTP v2, which is our cross-chain transfer protocol. And I'll touch on the new product that we released on July 22nd, which is Circle Gateway. And also Circle Gateway also allows for efficient cross-chain transfer, but in a very unique way when you compare that to CCTP v2. So I'll kind of highlight essentially what CCTP v2 does, go into details of how you can implement that in your application, and then touch on Circle Gateway, talk on how that works, and also show like our code examples, show Quickstart guides for that as well, so that developers can know or viewers can know how to get started building with that, and essentially touch on like how both products compare, CCTP v2 versus Circle Gateway. So that's essentially what I'll be talking through today. Over to you, Nisha.
Awesome. Yeah, let's just jump right into it. That sounds great.
Yeah, amazing. So if I can share my screen, let me know when my screen is up. Okay, let me share again 1 second. I'll just share like the entire thing.
Nice.
Okay.
Yep.
Okay, awesome. So I've got like the way it's going to go is that I have this slide set up, and this slide will allow me to talk through kind of like the theoretical nuances of each product. And after talking about the theory, I'll jump into the developer docs and also jump into the code walkthrough. So the view like so that developers can understand how this product kind of works. So essentially, when we talk about I want to start from like the Circle Developer Services, which is kind of like the Circle Developer Platform. We have an entire suite of tools presented to developers so that they can build easily on-chain. So we've got wallet, we've got contract, we've got Paymaster, and we've got CCTP. And newly introduced, which is the new product that was released on July 22nd, is Circle Gateway, and that will get added right here. But today, I'll focus on CCTP v2 and the new product. So when we talk about the Circle developer stack, or like the Circle developer or the Circle technology stack, this is essentially what we have, and this is what should etch to developers' brain. So going from stable coins to liquidity services to developer services to the supported blockchains, and kind of like how all these tools are available to developers, and also all the chains that have been supported. So starting with CCTP. So essentially, if you think about CCTP, named Cross-Chain Transfer Protocol, it's a permissionless on-chain utility tool that actually facilitates USDC transfers between blockchain by doing native burning and native minting. So you've got a source chain, which we can sort of call chain A. That's the source chain where USDC is coming from. And then we have another destination chain, which we can term as chain B. So a user or a developer wants to move efficiently USDC from chain A to chain B. And essentially in the past, what they would have to do is they would have to rely on bridges. Sometimes that's not safe. And that adds extra layer of friction to how USDC flows. So, but with CCTP, you can do a native burning where you sort of like burn the USDC on chain A, and then you do native minting on chain B, where you mint new USDC on chain B. So that allows you to do efficient cross-chain transfers. So CCTP is presented in two distinct versions. So we've got CCTP v1 and CCTP v2. So with CCTP v2, you can sort of think of that as a bigger set that encapsulate new stuff, new features, and CCTP v1. So CCTP v1 presents what we call standard transfer, which that takes like the normal time for finality, for blockchain finality. But CCTP v2 brings what we call fast transfer, which is faster than finality, and it presents hooks. So I'll show you kind of like a table where we compare both of these features in both of these features in our developer docs, so that you kind of gives you like the differences. But CCTP v2 is kind of like the latest and greatest, and it's available on the chains that we have numbered as shown. And I'll be showing you a demo of how we are going to move USDC from Optimism to Ethereum. So we see how that works, and we can test it out. And I've got like code that I'll walk through so you can understand everything step by step. But I'll continue with the theory or like the theoretical nuance of CCTP. So how is CCTP designed? CCTP is designed in kind of like a couple of composable smart contracts that is paired with what we call the off-chain attestation API. So to sort of like explain how that works, right? So there's if you're going from, like I said, chain A to chain B, the attestation sits in the middle. So when you make function call to the smart contract on chain A, which we know as the source chain, that bonds USDC on chain A, and for us to attest to the fact that that bond event actually took place, we need to fetch the attestation. So the attestation with fast transfer is available immediately. That's why it allows us have that cross-chain transfer really fast when you compare that to CCTP v1. With the attestation, armed with that attestation, we can then go on the destination chain to complete the transfer. So the app or the user then uses the attestation to mint USDC for the recipient on the destination chain. So we're moving from chain A to chain B, and with the attestation, we can easily mint USDC, or we can just mint USDC on the destination chain. And CCTP v2 presents hooks, which allows for additional operation and other logic that we can embed into the transfer flow to be triggered automatically. So we have a lot of information about this in our developer docs, which of course you can navigate to developers.circle.com to walk through to understand how all this thing kind of works if we want to learn more about it. So moving really quickly here, I've touched on CCTP v2. Then let's get into the demo. And in the demo, I'll be showing you kind of like how we're going to move USDC, or we're going to transfer USDC cross-chain from Optimism to Ethereum, and we're going to be doing that with CCTP. So like I said, the CCTP flow, or kind of like the CCTP steps, is kind of like in 4 stages. The first one is to approve USDC spending on the source chain. For this example, or for like the code walkthrough that I'm going to show, the source chain is Optimism Sepolia, which is the Optimism testnet blockchain. And then the second step, after approving the USDC spending on source chain, we're going to bond USDC on source chain using the token messenger, which is the smart contract function that is available on the source chain. And then after bonding, we're going to then retrieve the attestation from Circle's attestation service, which is literally making an API call. So we're going to be making that API call to receive an attestation, which you can sort of think of as kind of like a cryptographic proof that attests to the fact that the bond event has happened on chain A. And with the attestation, we go to the destination chain to mint USDC on the destination chain, which is Ethereum Sepolia. We're going to be using the message transmitter smart contract for that. So essentially,
quick questions there. So the sorry, can you scroll? Yeah, okay. So the token messenger and the message transmitter, these are like contracts that are part of Circle's suite?
Yes.
Part of CCTP? Okay, gotcha.
Yeah. So it's kind of like the CCTP smart contract.
Okay, got it.
Yeah. So awesome. So of course, kind of like a couple of setups quickly, but I'm going to be using the Vim client to interact with the blockchain to make to create wallet client and also create public client to sort of read data on chain, and then I'll use that to interact with the smart contract, bond the USDC, and also mint USDC on the destination chain. So I'm just doing a couple of imports here. Importing actions for the API call, importing create wallet client, and other stuff, other functions from Vim, and I'm importing private key to accounts to be able to create the account using my private keys, which is in the environment variable, but I'll not be showing that, so no need to show your. Make sure you're not showing your private key, but you need your private key to be able to interact with to be able to interact with the chain. And then I'm importing Sepolia and Optimism Sepolia from the Vim chains method. So kind of like the first step here is need to set up the Vim client and the wallet, right? So I need to initialize the wallet and the public client for both chains. So like I mentioned, we're going to be doing that on Optimism Sepolia and Ethereum Sepolia. And the first thing we're going to be doing is I'm going to be loading the private key from the environment variables, and I'm going to ensure that it starts with OX because that's what our Vim expects it. And if it's not, I try an error, so you kind of like check it back and make sure that everything is as expected. Then I'll be creating an account using the private key to account function, which creates an account from a private key and also sets that to this type as Vim expects it. So the next step after that is I'll create wallet client to interact to the blockchain for sending transactions. So this, of course, needs my private key. So that's why I put in the account, and then or setting up Optimism client with the create wallet client, right? And I pass in the chain, which is Optimism Sepolia, transport, and account. Right after that, I'm doing the same thing for Ethereum client, ensuring that I've passed the chain Sepolia, and then the transport so that I can interact with the chain, and then the account that I set up already. So the next step after that is I need to create public client to read the contract state and also wait for confirmations. The difference between this and the previous one is that I don't need my private key yet. So it's kind of like similar, but with the create public client, and I'm not passing the account because I don't need my private key. Yeah, I just want to read the public chain data. So I'll take a breather and then I'll move to step 2. So step 2 essentially is I need to define the constant, and the constant are kind of like, they don't change. These are the data that I need for me to be able to carry out this transaction. And essentially what they are CCTP contract addresses and the configuration parameter. So easily you can get this on in our developer documentation. You can just search for USDC addresses on this chain and also CCTP addresses. As a matter of fact, let me navigate back to the developer documentation so that I can sort of like show how to access that quite easily. So I'll just open this in a new tab and then I'll go back. So if you sort of come down here, contract addresses and interfaces. So because we're on the testnet and we're working with CCTP v2, so there's kind of like a switcher here. You switch from CCTP v1 to CCTP v2, so you get the information for CCTP v2 because that's what we're using in the demo. So for testnet, scroll a bit down and you see the testnet contract addresses. So for this demo, I just grabbed the Optimism Sepolia and the Ethereum Sepolia, and the domain interface, I grabbed that for Ethereum Sepolia and Optimism Sepolia. So going back to the code, you can see that I've got those constants here. The USDC address for Optimism Sepolia, USDC address for Ethereum Sepolia, and the message transmitter constant for that. So after setting the constant, the address, the contract addresses, right, I need to set the transfer configuration. So I'm sending from an address to another destination address. So I need to pass that destination address, which I've already set in the environment variable, as the recipient address. So the amount we want to transfer is just 1 USDC, just to test it. And then I need to set a maximum fee for the cross-chain transfer, which I already set here. And moving on, I need to format the destination address as byte 32 as it's expected. So I've done that right here as well. And remember the domain that I grabbed from the developer documentation 0 and 2. This is where I'm setting that for Optimism and Ethereum Sepolia. So the moment we're done with step 2, or the moment step 2 runs, we need to run step 3, which is so step 2 is kind of, we're not actually running step 2, we're running step 3, because if I scroll a bit down for that, just quick one, I just want to show you how everything comes together, right? So the first step actually running this to test it is we approve USDC, which is kind of like the step 1, and that's what I'm going to talk about right about here. So the step 3 in the code, but in the way it sort of function, that's the step 1. So approving USDC, we are going to approve the token messenger contract to spend USDC on our behalf, on the behalf of the user, because we are going to bond that in the next step. So we need to be able to approve that. So that's pretty straightforward. So for purpose of debugging, or just to understand, I'm console logging, approving USDC transfer, and this will come together when I actually run the demo, so you can see how everything flows step by step. So the next thing after that is set up my Optimism client. I use my Optimism client that I set up already. Then I use that to send a transaction, and sending this transaction to the USDC token contract address on the Optimism Sepolia. I passed my account and a little bit of data, the ABI, right? And then I passed the argument and to approve 10 USDC. So once that's done, I'll console log that in the terminal, and then I wait for the approval of transaction to be confirmed using the wait for transaction receipt, passing the hash to be able to confirm that transaction. Of course, it's asynchronous. That's why I'm passing await, and then I'll console log approve confirmed. So that's the first step in the way CCTP works, which is the approve of USDC. So once that's confirmed, once we have that approval to spend USDC on behalf of the user, once we have that confirmed, we move to the next stage, which is burning the USDC on the source chain. So in burning the USDC on the source chain, there are a couple of steps. So the first step is that we burn the specified amount of USDC on the user account. We create a message containing the transfer detail, and then we send that message to the destination chain. So, and the burn transaction returns, the function returns a transaction hash, which we're going to use in the following step to retrieve the attestation. Don't forget, I mentioned that we burn on the source chain, get attestation. With the attestation, we then use that to mint on the destination chain. So asynchronous function again, burning USDC and sort of moving that. So we send burn transaction to the token messenger with the Optimism client that we created, send the transaction. This is pretty same thing we did in the last step, only that we're passing a couple of arguments here, or passing the amount, the Ethereum Sepolia domain to indicate this is the destination chain we're going to, the destination address in byte 32, Optimism Sepolia USDC contract address, which we already set in the constant above, and then the destination caller in byte 32, the max fee that we set, and then we set a minimum finality threshold, which is a constant, by the way. So we'll console log this in the terminal, and then we return the transaction hash, which we need to retrieve attestation in the next step. So we've completed.
So okay. A quick question. So that the fee in this, is this paid in USDC or this is paid in native gas?
No, USDC actually.
Okay, gotcha.
Yeah. So once that's done, I need to go to the next step, which is to retrieve attestation, and retrieving the attestation from the Circle's attestation service, right? That also kind of like has a couple of steps in it, right? Detecting the bond transaction on the source chain, verifying that the transaction is valid, and then we generate the attestation, which, like I said, I related that to a cryptographic proof. So the function returns the bond transaction, the transaction hash of the bond transaction, and the attestation object, which contains two things, contains the message and the attestation data. So moving on, kind of like this is the URL of the endpoint that we're going to like hit to get the attestation. So we're passing the domain for Optimism, which is kind of like the source chain, right? Because we're trying to verify that the bond event on the source chain actually took place. We'll pass the transaction hash. So we're passing the transaction hash right here. So we're making this API request using Axios, and we await that to make the call. Once we get the data back, once we get the response back, we check if it's complete. If the status is complete, then we go ahead to console log. Okay, this happened successfully, and then we return the message. So don't forget, I said this contains like the message and the attestation data. So we're grabbing we are going to data messages, and we're grabbing the message, the first one in the JSON response that will go back. So we're going to console log, waiting for attestation, and right after that we await, and then we're doing some error logging here to catch some errors. And after that step is done, we're done with we're done burning on the source chain. Attestation in the middle is done. We then need to mint on the destination chain. So
I do have one more quick question there.
yes, guys.
So if I wanted to see, like, is there some kind of like UI place where I can see the attestation happening? Oh, there is. Okay.
Yeah. I'll actually show the UI after this, but I just wanted to sort of like walk through kind of like the code, so that
Absolutely.
so that's super clear. I'll be showing that right after the demo, and it's kind of similar, but the UI is a fully fledged application that we built to help developer kind of get started. You can clone it, clone that UI, and then you can use that in your own application. And we've seen a lot of developers actually using that in their existing application. So
Amazing.
the last step, which is minting USDC, is that we're going to mint USDC on the destination chain using the attestation, right? So like I said, contains a couple of steps. Again, verify if the attestation is valid, check the message hasn't been processed before, and then we'll mint corresponding amount of USDC to the recipient. So that's pretty straightforward, same like we did the last time. The only difference is that we're using the Ethereum client to actually send the transaction, because we're now on the destination chain. So right here, the message transmitter, and we're sending the main transaction to the message transmitter contract. Don't forget, when I started this demo, I said we've got a couple of smart contracts on this chain. So we're eating the message transmitter contract. So we're passing the data, the ABI, and then we're console logging the mint transaction hash, and that's pretty much it. So the last step, right, just runs all these functions sequentially. So the first step is to approve the USDC. After approving USDC, we burn USDC on Optimism Sepolia with the burn USDC function. After that, right in the middle, we get the attestations, attestation to verify that the burn event actually took place, and we're using the retrieve attestation function that we walked through previously with the bond transaction hash, and then we'll mint USDC on Ethereum Sepolia with the attestation in the function, and that's pretty much it. So, and I've got like this extra step to just check the balance of like what I've got in my wallet, so you can actually see. So I've got this much in my testnet, and then I'm just going to like test this, run npx cctp.ts, and like I said, with the console log, helpful console log that we already did, you can see how everything moves step by step. The first one was to approve the USDC for transfer. We got that approval with the hash, approval confirmed. Then we need to burn on Optimism Sepolia. After burning on Optimism Sepolia, we retrieve the attestation. Armed with the attestation, now we make that API call, and then we're able to retrieve the attestation successfully. With the attestation, we then mint USDC on Ethereum Sepolia, and that's done. So we actually I've actually did a couple of stuff with the balances, but if you look at it, we have 67 here. Previously we had 68, so that showed that we actually move one USDC from Optimism to Ethereum. So, oh, sorry, the right here, 67, 66. So that showed that we move from Optimism Sepolia to Ethereum Sepolia. So That's pretty much it. That's how CCTP v2 works. Really straightforward, and it's super fast for us to do cross-chain transfer efficiently. So let me actually show the UI that you talked about, and we're going to do the same step again. So but you see that in kind of like a UI format, everything embedded, and that's how a developer would present this application to a user, and that's how you'd have it embedded in a real world application. So I'm going to navigate back, probably stop sharing so that I can pull that up and then share my screen again, if that's okay.
Yeah. I do have one more question. So
Yes.
this was V2.
Yes.
This didn't use the hooks feature, right?
Yes, you didn't use the hooks feature. So if you want, if
Yeah.
you'd want to use the hooks feature, we've got like detailed step in our developer documentation of how you sort of like use the hooks feature for V2.
Okay.
Yeah.
Cool.
So let me and I'll show where that is also in the developer documentation. But let me pull up this nice UI thing that we've got set up. Oh, okay, awesome. I'll go back to sharing my screen now so that we can have that, and I'll still run through similar step, only that this time around is a little more intuitive, because you see like a nice UI. So we've got this at reply.com. I'll actually drop the link in chat so that they can have access to it.
Yeah, we can put this in the in the notes for the show as well.
Okay, amazing, awesome. So yes, so with the link, developers can actually clone this. So we recommend that they remix the app. So once they clone it, they have access to this application, right, with this code base, and you can see all the chains that are actually like supported, right, right in the documentation. And essentially what I would do is I'm just going to hide this, but all the code we have, like all the code right I just explain like everything I just walked through is like similar stuff, but only that this is kind of like a full web application. And then I'm just going to run this. So of course your private key is in the secret, ensure that it's well saved. I'm not going to show that, but Replit has a nice way of like showing that helping you keep your secret. Okay, so this is our CCTP v2 web application. It's an open source reward application that we have, and we recommend that the developers actually clone this. So you can click on this button to remix the app, and it presents kind of like this nice user interface for you to understand how CCTP works. And what I'm going to do is, so when you actually remix this app, it takes you to this code base, and in this code base you can run it, you can actually see the code. Essentially the code I just walked through is similar to this stuff, so but only that we have it embedded in like with a nice front end and a nice back end, like database functionality and everything, just for you to test transfers, cross-chain transfers. So ensure that your environment variables like your private key is in secret, and Replit has a nice way of helping you keep your secret. So but we do recommend that you use the secret feature to store your environment variable, your private key to actually test this out. And I'll be walking through CCTP v2, the same setup we had in the previous example, only that we've got this in a nice UI, and you can sort of see like the entire process happen in like in the log that we've created. So I'll select Optimism Sepolia and then Ethereum Sepolia, and this is how a developer would show like CCTP in like a nice user interface to kind of like a user. And I'll have one USDC, and then I'll start the transfer. So that same step to what I explained previously: approval, bond, attestation, and mint. So you can see how all this is happening like real time. There's a user interface, and you can see the gas amount that was spent for this transaction, and then the transaction hash, and you can actually take this and verify that publicly. So we really recommend that if you are building with CCTP, we recommend that you clone this app. It has everything that you need: the front end, the back end, the CCTP logic for all the chains that are supported on CCTP v2. So I'll pause for any question before I move on.
So I wanted to know a little bit about how hooks works. It seems like that would, make it easier for developers, fewer clicks. So can you tell me a little bit about hooks?
Yeah. So part of like the core what CCTP v2 actually present is hooks, right? And with hooks, you are able to like support or like provide post transfer automation actions, right? And we're actually working on like detailed examples to help developers actually understand how to implement hooks in their application. And it will be right in the hook section, like in the developer docs in the hook section. So pretty much if anyone wants to like learn more about hooks, they'll be able to find that in like the developer documentation.
Super cool. Okay,
Yeah.
looking forward to it.
Yeah. So I think now that we've touched on CCTP v2, sorry, can you confirm if my camera is still showing?
Yeah, it's showing.
Okay, awesome. So now that we've touched on CCTP, now that we've covered CCTP v2, I really want to share Circle Gateway, which is kind of like something new we just launched. We launched July 22nd, which are like from, I don't know like the dates this will be released, but we launched it on July 22nd. And essentially, I'll explain like Circle Gateway, and let me just go back to my slides. That's much easier. So in my slide, right? Yes, so I prepared this to communicate the solution that the solution that Circle Gateway present. So the essential, like the problem that Circle Gateway actually solves is, if you see on the left side, you've got USDC on multiple chains, and this is the reality of most on-chain users right now. So you've got some USDC on Avalanche, you've got some USDC on Base and on Ethereum. And if you would like to maybe transact on like a different chain, you'd have to find a way to move some USDC to the other chain before you do the transfer. And that adds a lot of friction, not only to the users, but also to liquidity providers, right? As they often find that friction when they're providing USDC liquidity. So the solution is a unified balance, which we call Circle Gateway. And with Circle Gateway, you're able to present this unified balance, and you're able to have all your USDC available to you on all these chains easily. And I would explain how that works, right? But essentially with this unified balance, like I said, you're able to like transact USDC from any chain of choice. So Circle Gateway presents this instant access to USDC, right, and gives you ability to serve liquidity demands on multiple chains through one integration with less working capital. And like I said, for liquidity provider, where you'd have to have like liquidity on this particular chain, you'd have to have liquidity on this other chain. But with Gateway, you don't need to worry about that. You can just have just one integration and spend in multiple places. Circle Gateway is non-custodial. That means users have full control to their USDC. Essentially, what you're doing is you're actually depositing your USDC in something that we call the gateway contract. And with the gateway contract, you are like actually have access to like do what you want, and the funds can only be moved with the user's signature, and withdrawals are trustless. So currently, Gateway is available on testnet now. 3 chains, right? Avalanche, Base, and Ethereum, with mainnet coming soon. So we've got like developer documentation ready, Quickstart guide ready for you to be able to like understand and dive deep and start building with Circle Gateway. But essentially, how Circle Gateway works is there are a couple of steps bundled into these 3 categories. Step 1, step 2, step 3. So the first one is the deposit step. And in the deposit step, what you're essentially doing is you're depositing USDC to fund your unified balance on any supported chain. Right now, as at the time of this video, Avalanche, Base, and Ethereum. But you're depositing your USDC into this unified balance on these chains, and you deposit to a gateway wallet contract, which is kind of like the first step. And after it's been finalized, after the deposit is being finalized, the deposit forms a unified balance that can be tracked by the gateway system. So what that actually means is that I'll probably send maybe 1 USDC from Avalanche, 1 USDC from Ethereum, 1 USDC from Base, and my unified balance will be 3 USDC available to me to transact on any of those chains. So one thing you have to note is that this initial step actually on Avalanche finality is instant, like it's reached almost immediately, but you have to wait for a couple of minutes for Base and Ethereum. So I think that is about 15 minutes to 20 minutes. But once finality is reached on those chains, Base and Ethereum, you can transact in less than 500 milliseconds, right? It's super fast. So you can transact in 500 milliseconds. And what we do recommend is that you just have to like wait for the initial deposit step. But once you move all your USDC, once it's been deposited into that unified balance, you can do as you wish. So for the transfer step, what you do is you submit a signed bond intent via the gateway API, which actually just involves you signing and sending a bond request to the gateway API, and then the gateway system verifies and returns a signed attestation. After that, you can instantly mint USDC on any of those supported destination chain. For example, I can move from Avalanche, Ethereum, maybe send one USDC from Avalanche and Ethereum to Base, and I use my attestation to mint the USDC with the ability to trigger arbitrary like atomic actions via hooks. Again, like I said, we don't have like a lot more like documentation ready on those, but we would add that into like the developer doc so you can see like examples of how all this thing works. And the gateway system ensures an equal amount is bound on the source chain. So essentially, this is how like gateway works. But I know like developers will love to like of course hack around and actually understand and test things out. Even though I don't want like have enough time to actually walk through the code one after the other because it's a little bit involved, I would actually point us to the resources and we can see right here. So there's this open source Quickstart that we actually have in the EVM gateway contract, right? It's a Quickstart that is available and you can actually run through this really quickly. You can clone it and then run through this. The step is really straightforward. You have your private key and then you run two files actually. You run the deposit.js, which would actually take care of the first step that I talked about. Move the USDC from individual balances on this individual supported chains, Avalanche based Ethereum, to a unified balance. This is the one that is time consuming because of course you have to wait for a couple of minutes for finality to be reached on Base and Ethereum. But once that's done, you can move right to the second step, which is the transfer, which is running transfer.js. So like you said, yeah, once USDC has been deposited, the transaction needs to be finalized. But on Ethereum and Base, you need to wait roughly for 20 minutes. So once that's done, you can run your transfer and you can mint on any chain as you wish. So the code is available. This is the deposit.js file. It's got everything that you need. And this example actually walks through depositing 10 USDC from Ethereum, from Base, from Avalanche into the gateway contract to form that unified balance. But once you form that unified balance, you can transfer. And this example shows how to transfer from Ethereum and Avalanche to mint on Base. So once you move from Ethereum and Avalanche unified balance, you can then mint the equal amount on Base. So this is Circle Gateway. We would love for developers to start building this. We want to understand the kind of use cases that developers can actually build with this stuff. You can join our Discord for more information on this. You can talk to me directly if you need help actually integrating this into your application. And like I said, it's really, really new, coming out fresh from Circle. And we'd love to get more developers to actually start building with this.
So just one quick thing, just to make sure that I understand this. So like the deposit step is the one that takes time, but everything else is really quick.
Yes, right? everything is actually really quick. Like I said, it's actually instant. It's less than 500 milliseconds, right? For the transfer, it's like fast.
So, like, let's say I have some, USDC on Base and
Yeah,
Avalanche and EVM or
yes,
Ethereum. So then,
yeah,
like, the first thing I would do is I would, run the deposits on each of these, and
yeah,
after that, I can kind of move tokens freely, like
exactly.
very quickly between these chains.
Between those chains. So
That's so awesome.
that solves that problem that I presented initially here, that you'd have to like find a way to transfer from Ethereum, like bridge, and find a way to maybe find liquidity. No, that solves it because you have this balance available to you on all these supported chains.
Mm,
Yeah,
super cool. Yeah,
yeah,
fragmented liquidity is a big problem, so this is awesome.
yeah. Yeah. I was actually hoping you'd ask me this question, but since you didn't ask, I'll go right to it, because if like you've actually been following, you notice that CCTP and Circle Gateway, they kind of like solve the same like cross chain like issues. So how do
Mhm.
they compare with each other? What's the difference? What's one best known for? What are the features that separate one from the other? So let me quickly touch on that.
Yeah,
So
please.
yeah, so like I said in the demo we walked through, you could see that CCTP v2, we actually moved from source chain A to B, or we can move from source chain B to destination chain A. So it's CCTP v2 is more like bridging from one chain to another, while
Mm,
Circle Gateway gives you the ability to hold chain abstracted USDC balance that is instantly accessible on multiple chains. So that's kind of like the difference. So with CCTP v2, you can just bridge, move from A to B or B to A. But with Gateway, you actually have your USDC available on like ABC. So you can spend instantly
same time.
at exactly
Super cool.
with unified balance.
Mm,
So although they've got like different use cases, like what we've seen them people use it for, like for CCTP v2, we've seen like efficient rebalancing, gateway unified balances for like instant and secure transfer. You don't need like any rebalancing. You don't need like to manage liquidity on like imagine like a liquidity provider that needs to manage like liquidity on Avalanche, on Base, on Ethereum. You don't need that. You can just have everything in one on the gateway in the gateway contract, and then you can route as you wish.
super, super cool.
Yeah, so that's kind of like the main difference, although there are kind
Mhm.
of like more information on like the architecture, the features, the network, the supported blockchains, right? With more to come, and then how it's being custodied, like both of them is still non-custodial, and the transfer speed, right? Depending on the source chain and finality, transfer usually takes to like 8 seconds to 20 seconds. If you remember the demo we did, well, I think it was probably like 90 seconds from Optimism to Ethereum was super fast also, but for this is like super super fast. Once you cross that deposit step of
Yeah.
like having all your USDC in the unified balance, everything from there is like this.
Amazing. Yeah, and like the deposit step is that's the thing that you don't really expect to be doing all that often, Deposit one time and
Exactly.
then you can move.
Yeah,
Okay,
exactly.
awesome.
Exactly.
Super, super
So
cool.
yeah.
What does
So
the like
yeah.
when's it coming to mainnet? That's what I want to know, What can we use it?
Oh, okay.
The rollout?
I wouldn't have more information on that, but
Okay.
yeah, but you can actually join our Discord server. Join our
Mhm.
Discord server. You'll be available. You have all the information that you need right there. Our X, you can follow Build on Seku. So any new information, you'd obviously find it there, and also like our developer documentation. I actually wanted to show kind of like more resources in the slide, right? Because we have like a YouTube channel. Yeah, so we have like our YouTube channel where you can find all the content. So Build on Circle on YouTube, Build on Circle on X. Discord is circle.com/Discord. Replit, where we have a lot of sample application, like a lot of example application, full some end-to-end application that has like the front end, the back end. You can clone and you can start building. And we actually built this to make it easy for developers to actually integrate the tech. We've done a lot of work, and we made it available, make it easy for developers to start building. I've created a ton of videos on YouTube. My colleagues have also created a ton of videos on YouTube as well, and it's like easily available for developers to start building. So I really recommend that you join our Discord. You can ping me blessing slash circle once you do @blessing, my name comes up, so you can tag me on Discord. I'll be open to answer any question and help you integrate this tech into your application.
Awesome.
Yeah.
And so it looks like you guys have like these bounties out. You guys have these hackathons. Like,
yes.
What are the kind of projects that you want to see built on top of Gateway, on top of V2?
Yeah. So essentially, as a matter of fact, we actually just rounded up Ethereum global hackathon in Cannes, France, and we actually saw like really interesting applications that were submitted. We saw ranging from like multi-chain infrastructure, multi-chain payment application, to like Gasless, which is Paymaster. I didn't have the opportunity to cover Paymaster today, but if you guys can invite me back, I can also touch on Paymaster. But that's also like an interesting tech that would actually dive deep into the code, into the nuances of how you can actually use a Paymaster to offer gasless infrastructure where you actually pay the gas in USDC, right? Imagine a world where users, developers don't have to source for native token. They just transact with USDC, kind of like the way we have it in the traditional world of transaction fees. There's no a time where you want to like buy stuff online that you have to think of like, oh, how do I source my transaction fees? You just see that deducted and you're okay with it. And that's what Paymaster actually presents. And we saw applications on like gasless or like USDC sponsored gas transactions, and with our Circle Web3 services, which is also kind of like our other product suite that we've got, where we have like Circle Wallet, contract, and gas station. And with gas station, you can actually offer like gasless transactions where we sponsor the gas on your behalf with gas stations. And we saw a lot of applications on that, and we saw compliant regulated kind of like applications using our compliance engine, because something that developers are thinking about is that, okay, I don't want to build something cool. Like what I'm building, how is it, like, how do I take care of compliance? You can use our compliance engine for that. And we've got like embedded like features that takes care of that for you. So we're looking for applications on that as well. So just to sort of like summarize, multi-chain application using CCTP v2 essentially, or newly presented Circle Gateway, and gasless transaction using gas station, and USDC gas transaction, or like USDC sponsored gas with Circle Paymaster, and then wallet, maybe like applications that present like efficient use of wallet and with compliance baked in. So those are kind of like top 4 categories that we're looking out for from the bounties. And like I said, we just rounded up Ethereum Global Can, where we saw a lot of innovative applications from developers. I was actually really surprised at the breadth of the innovation that is coming out from the space.
Yeah, the Paymasters, and like I think that works really well with Gateway. You know,
yes.
Now you have like fully unified, like gas is USDC, all USDC is the same. Like it just makes a lot of sense.
That's exactly. Cool. Exactly. So a developer can actually think of like an application that sort of like wraps everything together to solve fragmentation of liquidity, to solve user experience issues, and user just transacts. They don't even know what's happening in the background.
That's the dream. Just spend it. Just that's it.
Exactly. Exactly. Yeah.
All right. Well, I think that's all we have. Unless there's something else you want to talk about, we can.
No. I think it would be really cool to have like an episode maybe on Circle Paymaster, where I actually walk through how you can actually pay for transactions using USDC.
Yeah. Oh, I would be so down for that. That'd be really cool. We'll look into it.
Nice.
But cool. Okay. Looks like that's what we have. Thank you so much, Blessing. This was really cool.
Thank you, Nishad, for having me.
Yeah, of course. And all of the resources mentioned, we'll put them in the description. So anyone watching this, check the description out. Tons of resources from Circle. We'll have it all there.
Yes. Amazing. Thank you.
Thanks, guys. Yeah.